This is part 2 of the Chapter 10 review, and we're continuing on with problem 17. In this problem, it says tell whether the red arcs are congruent. Explain why or why not. Well, I had to get some help on this because I can't see the red from any other color in here, and I've been told that ST is red and YZ is red. But we're going to go ahead and talk about all these arcs just to make sure that we get everything covered. You can see that this circle that contains arc ST is a smaller circle than the circle that contains YZ. That means the radius PY is bigger than the radius SP. So these two circles are not congruent. Therefore, because we have ST and YZ in different circles, they are not congruent arcs. They are similar arcs because they have the same measure. Since this angle and this angle are vertical angles, this arc and this arc have the same measure, but that means they're similar arcs, not congruent arcs. Now, arc ST is congruent to arc WX, and arc QR is congruent to arc YZ, just as SW is congruent to TX and QY is congruent to RZ. What's required for congruence is that the arcs must be in the same or congruent circles, and they have to have the same measure. So, for 17, no. They're not congruent. They are similar. Now let's move on to 18. Here, I'm told that AB is red and EF is red. Now you can see that the radii of both circles is 6. That means that circle C and circle D are congruent circles. So, as the definition goes, if two arcs are in the same or congruent circle and they have the same measure, then the arcs are congruent. So this arc has a measure of 95 degrees because that's the measure of its central angle, and this arc has a measure of 95 degrees because that's the measure of its central angle. So yes, these two arcs are congruent because they're in congruent circles and they have the same measure. So yes, they're congruent. Alright, let's move on to problem 19. In problem 19, we're looking for the measure of arc AB. So this is AB, and we know that if this central angle is 61 and this chord is congruent to this chord, then we know that this arc is congruent to that arc. Since 61 is the measure of this arc, then we know that 61 has to be the measure of this arc. Congruent chords implies congruent arcs. So, for number 19, the measure of AB equals 61 degrees. In problem 20, we have a chord that is the perpendicular bisector of another chord. Now we know the theorem states that if one chord is the perpendicular bisector of a second chord, then that first chord is a diameter. And we know that if a diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. So we know that arc BD is being cut in half, which means AD is congruent to AB, and therefore our arc AB is 65. So in 20, arc AB equals 65 degrees. And now on to 21. Here we have two chords that are equidistant from the center. This perpendicular segment from the center to the chord represents the distance, and it is congruent to the distance from this chord to the center. So these two chords are equidistant. The theorem says that if two chords are equidistant, then the chords are congruent, and we know that congruent chords gives us congruent arcs, and so this arc is congruent to that arc. That means that the measure of arc AB is going to be 91 degrees. And I have to fix this here. That's supposed to be measure. So 21, the measure of arc AB equals 91 degrees. And now on to problem 22. In problem 22, we're given a little bit more complex situation. We're told that segment QN, the length of QN, equals the length of QP, which equals 10. So QN is the distance from chord JK to the center, and QP is the distance from chord ML to the center, and they're equal. They equal 10. So just for kicks, we can go ahead and write that in, just so that we know what we're working with. So these two lengths are 10. We know that JK is given by the expression 4x, and the length of LM is given by 6x minus 24. Well, since these two chords are the same distance from the center, we know, just as in the last problem, that this chord equals this chord, and if we have congruent chords, we have congruent corresponding arcs. So that means that 4x equals 6x minus 24 because the arcs are congruent. Now that we've gotten all the information the problem's given, what is the problem looking for? The problem is asking us find the radius of circle Q. So the radius would be the distance from the center to any one of the endpoints of the chords. Well, I'm going to go ahead and draw in a radius. So let's draw in a radius here. And so we're looking for that radius. In order to solve for that radius, we see that we have a nice little right triangle in here, and we have one of the legs of the triangle already. So if we only had this leg, we'd be in good shape. We'd be able to determine the length of that hypotenuse. The radius is the hypotenuse of this right triangle. Well, we have an expression for the entire segment here, for this entire chord, and we have an expression for this chord. So we should be able to solve these two expressions because this equals this. We should be able to solve for x, substitute it back into one of these expressions, and find the length of these chords. Since these chords are congruent, then all we need to do is find the length of one of the chords. Now, if you were to take this segment and extend it to meet the circle at both ends, you can clearly see that this would be a diameter. And since this segment is perpendicular to the chord, we again have a situation where we have a diameter perpendicular to a chord, which means that this segment is bisecting this chord. So MP is going to be equal to PL. Now that tells us that once we've found the length of the chord, we simply divide it by 2, and we've got this leg length. And we'll have what we need to be able to find the hypotenuse. So the next step here is to go ahead and set these two equal to each other and solve for x. So we have 4x equals 6x minus 24. Let's go ahead and solve for x. I'm going to pull the x's over here because I like working with positives. So we have 0 equals 2x minus 24. Add 24. 24 equals 2x. Divide by 2. 12 equals x. So now that x is 12, we can substitute that in either in here or in here. So it's easier to substitute it in here. So 4 times 12 gives us 48. Now we know the length of ML and the length of JK is 48. Now, we know that MP is half of that length. So 48 divided by 2 is 24. And that's going to equal the length of MP. So let's go ahead and write that in. So this is 24. Now, we can find this value. Let's call this x up here. Now, if we look at this and we look carefully, you can see that these two are related. If we divide this by 2, we get 5. And if we divide this by 2, we get 12. So that makes this a 5, 12, 13 Pythagorean triple, which means this side would be 26. But let's assume, for the sake of discussion, that you didn't see that. That's all we have to do is use Pythagorean theorem here. In that case, we can say that 10 squared plus 24 squared equals x squared. If we square root both sides, on the right we have x, and here we have the square root of 100 plus 24 squared, which is 576, and that gives us the square root of 676, and you put that in your calculator and you come out with 26. So x equals 26. So that's our radius, 26. You can see that it helps a lot if you know your Pythagorean triples, but it's not necessary. It just takes a little longer. The only difference being how much time it takes you to perform a test. Okay, let's move on to problem 23. In problem 23, we're dealing with an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords. And the theorem states that the measure of an inscribed angle is 1/2 its intercepted arc, and since this is 1/2 this must be twice that. So that means that in 23 here, x equals 80 degrees, because this is half that. Alright, 24. Here we have an inscribed quadrilateral. And the theorem here states that if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So we can say 4r plus 100 equals 180, 4r equals 80, and r equals 20. For Q, we can see that this plus this equals 180, so Q plus 80 equals 180. Subtract 80, Q equals 100. Fairly straightforward problems. Alright, we'll go ahead and wrap up this part here, and we'll start problem 25 in the next part. So I'll talk to you in the next video.